Next, we will talk about the different metal types. Many different metals are required in the manufacture and repair of space lift vehicles. This is a result of the varying needs with respect to strength, weight, durability, and resistance to deterioration of the specific structures of parts. The term ferrous applies to a group of metals having iron as their principal constituent. The first type of ferrous metal is carbon steel. Carbon steel derives its physical properties from the presence of varying quantities of carbon. Arguably the most common type of steel produced worldwide, the carbon steels are used in almost every aspect of our daily lives. The second ferrous metal is nickel steel. These are produced by combining nickel with carbon steel. Steel containing from 3 to 3.75% nickel are commonly used. Nickel increases the hardness, tensile strength, and elastic limit of steel without appreciably decreasing the ductility. The third ferrous metal is chromium steel. Chromium steels are high in hardness, strength, and corrosion-resistant properties and are particularly adaptable for heat-treated forgings which require greater toughness and strength than may be obtained in plain carbon steel. It can be used for such articles in the balls and rollers of anti-friction bearings. The term non-ferrous refers to all metals which have elements other than iron as their base or principal constituent. This group includes such metals as aluminum, titanium, copper, and magnesium, as well as such alloyed metals as Monel and Babbitt. Aluminum is one of the most widely used metals in modern construction. It is vital to industry because of its high strength-to-weight ratio and its comparative ease of fabrication. The outstanding characteristic of aluminum is its light weight. Aluminum melts at a comparably low temperature of 1250 degrees Fahrenheit. It is non-magnetic and is an excellent conductor. Commercially pure aluminum has a tensile strength of about 13,000 psi, but by rolling or other cold working processes, its strength may be approximately doubled. Aluminum alloys, although strong, are easily worked because they are malleable and ductile. Most aluminum alloy sheet stock used in spacecraft construction ranges from 0.016 to 0.0196 inches in thickness. The various types of aluminum alloys may be divided into two general classes, wrought and casting. Aluminum alloy, whether it is wrought aluminum or wrought aluminum alloy, are designated by a 4-digit index system. Aluminum identified by the code number 1100 is 99% commercially pure aluminum. In the 4-digit numbering system for identifying aluminum alloys, the first digit shows the major alloy used for the aluminum. With all-clad aluminum, the terms all-clad and pure-clad are used to designate sheets that consist of an aluminum alloy core coated with a layer of pure aluminum to a depth of approximately 5.5% on each side. The pure aluminum coating affords a dual protection for the core, preventing contact with any corrosive agents, and protecting the core electrolytically by preventing any attack caused by scratching or from other abrasions. The use of titanium and titanium alloys is widespread. It is used by many commercial enterprises and is in constant demand for such items as pumps, screens, and other tools and fixtures where corrosion attack is prevalent. In spacecraft construction and repair, titanium is used for fuselage skins, engine shrouds, firewalls, frames, fittings, and fasteners. Copper is one of the most widely distributed non-ferrous metals. It is the only reddish-colored metal and is second only to silver in electrical conductivity. Its use as a structural material is limited because of its great weight. However, some of the outstanding characteristics, such as its high electrical and heat conductivity, in many cases overbalance the weight factor. With copper alloys, small amounts of alloying elements are added to copper to improve certain characteristics of the metal. Alloying copper can increase or reduce its strength, hardness, electrical or thermal conductivity, or corrosion resistance. The addition of a substance to improve one property may have unintended effects on other properties. This section describes the effects of varying alloying elements with copper to create copper alloys. Monel, the leading high nickel alloy, combines the properties of high strength and excellent corrosion resistance. The metal consists of 68% nickel, 29% copper, 0.2% iron, 1% manganese, and 1.8% other elements. It cannot be hardened by heat treatment. Magnesium, the world's lightest structural metal, is a silvery white material weighing only 2/3 as much as aluminum. Magnesium does not possess sufficient strength in its pure state for structural uses, but when alloyed with zinc, aluminum, and manganese, it produces an alloy having the highest strength-to-weight ratio of any of the commonly used metals.